We have another example on the board. We have to find I total first. Please notice that we have given I1. I1 goes through the resistor R1, but please also notice that this is going to be also equal to the total current, right, which will go through the whole circuit. So I can say that I total is equal to I1, which is equal 15 milliamps. Okay, so we found I total. Next, we can use KCL, Kirchhoff current law, which says that the sum of these two currents in the parallel circuit is going to give me I total. Okay, so let me write down the formula, which says I total, which is also equal, in my case, I1, is equal I2 plus I3. We have to find I3. I2 is given. So if you are going to solve this formula for I3, don't forget that I total is equal to I1, so I can use I total or I1. So I'm going to have I3 is equal I total minus I2, where I total is equal 15 milliamps minus I2, which is equal 3 milliamps. This is equal 12 milliamps. Okay, so this is the current which goes through the resistor R3. So we found I3. Now we're supposed to realize that voltage V3, which is equal to 12 volts, is going to be equal to the voltage across resistor R2, because these two components are in parallel. That's why I'm going to write that V3 is equal to V2, and this is equal to 12 volts. So we found V2. Please notice that the sum of the voltages, I mean V1 plus voltage which we have across these two resistors, which is 12 volts, is going to give me voltage source. So let me rewrite the problem, I mean the diagram, and I have, this is my R1 and this is going to be resistor R2, 3. This is the combination of these two resistors. Okay, so if I have voltage across these two resistors, right, because they're in parallel, the voltage across each of them is the same, so I have 12 volts, and I have voltage source given, which is equal 25 volts, I can find very easy voltage across resistor R1 by using KVL. KVL says that voltage source, okay, voltage source is equal voltage across resistor 1 plus voltage across resistor 2, 3, okay, where voltage across resistor 2, 3 is the voltage across these two resistors, okay. Again, these two components are in parallel, that's why the voltage is the same. So if you are going to solve this formula for V1, you will have V1 equals voltage source minus V23, where voltage source is equal 25 volts minus V23, which is equal 12 volts. Everything is equal 13 volts. Okay, so we found the voltage across resistor R1. Now we are ready to find the resistances in our circuit. Resistance R1 is equal voltage across resistor R1 divided by the current which goes through resistor R1. So we found that V1 is equal 13 volts. So this is voltage across resistor R1, okay, voltage across this resistor, divided by the current which goes through this resistor, 15 milliamps. This is equal 867 ohms. Okay, so this is the resistance of my resistor R1. Okay, let me cross this out because we found it. Next, we're supposed to find resistance R2. R2 is equal V2 over I2. V2 is equal 12 volts over I2, 3 milliamps. Okay, the current which goes through resistor R2 is 3 milliamps. This is equal 4 kiloohms. Okay, so this is the resistance of resistor R2. Next, we can find resistance of resistor R3. R3 is equal V3 over I3, which is equal 12 volts over I3. I3 is equal 12 milliamps. This is equal 1 kilo. Okay. Next, we're supposed to find R total. R total is equal voltage source over I total, where voltage source is equal 25 volts and I total is equal to I1, which is in our case 15 milliamps. So I have 25 volts over 15 milliamps. This is equal 1.67 kiloohms. Okay, so this is the total resistance, okay, of my circuit. Next, we're supposed to find, let me just cross this out, we have to find the total power. Total power, P total, is equal I total times voltage source, where I total is equal 15 milliamps times voltage source, which is equal 25 volts. This is equal 375 milliwatts. Okay, so this is the total power in my circuit. Next, we're supposed to find the power at resistor R1. So I have P1 is equal I1 squared times R1, where I1 is equal 15 milliamps raised to the second power times R1, which is equal 867 ohms. 867 ohms. Everything is equal 195.07 milliwatts. Okay, so this is the power at resistor R1. Next, we're supposed to find P2. P2 is equal I2 raised to the second power times R2, which is equal I2 is equal 3 milliamps, so I have 3 milliamps raised to the second power times R2, and we found that R2 is equal 4 kiloohms. Everything is equal 36 milliwatts. Okay, so next we're supposed to find P3. We found P1, P2. P3 is equal I3 raised to the second power times R3. So this is equal I3 12 milliamps raised to the second power times R3, and we found that R3 is equal to 1 kilo ohm. Everything is equal 144 milliwatts. And someone can say that the problem is solved, but it's always good to verify the answers. You have to realize that if you are going to add all these three powers, P1, P2, and P3, you're supposed to get approximately this value. So if P total equals P1 plus P2 plus P3. Okay, please notice that I always write the formulas first. I want you to always write the formula first because it's the only way to remember the formulas. Many students complain that they have difficulties to remember formulas. They don't remember because they don't write them. Okay, so always write the formula first. So P1 we found is equal to 195.07 milliwatts plus 36 milliwatts plus 144 milliwatts. So P total is equal 375.07 milliwatts. Please notice that these two values are almost the same. So it means that we solved the problem correctly.